had a bunch of questions about the hard problem on that homework assignment, which is due tonight. So I'm going to give you a little guidance on it. Once you get into it, the hardest problem, which one is the hardest problem on there? The what? The $100 bill one, right? The football field. So on that problem, there are several steps, and there are lots of steps, and there are a lot of conversions between units that you need to take. First of all, you need to find out what is the area of the football field. All right? It's 300 feet by, what, like 60-something feet? 160, okay. So it's 300 feet by 160 feet. So you need to figure out the area of the football field. And then you need to figure out the area of the $100 bill. And it's, I forget, so many inches by so many inches. 6 by 2.5 inches. So you need to find out what that is. And then you need to convert them to the right units. So make sure that they're in consistent units. Then you need to figure out how many stacks of bills can I put onto that football field. And in order to do that, you're going to divide the area of the football field in either square feet or square inches by the area of the bill in either square feet or square inches. And then you can figure out how many stacks of bills you can use to cover this football field all the way around. Okie dokie, y'all with me? Now, once you know the number of stacks, then you need to figure out how many bills are there. Now be careful, because it says the debt is like 10 trillion. I think it's more than that now, but the debt is 10 trillion. But you're actually dealing with $1 trillion, which is 10 to the 13th dollars. So you don't get to write money values in scientific notation very often, but you do here. Hey, we should start using scientific notation to write dollar amounts. It's just a thought. Okay, so you have 10 to the 13th dollars. You want to find out how many bills you're dealing with. Well, you're not dealing with 10 to the 13th, right? Because you have $100 bills. So in order to find out the number of bills, you're going to divide by $100. So this gives you 10 to the 11th bills. Okay? Now once you know the number of bills, and you know the number of stacks that you have by dividing the two areas, you can figure out how many bills are in each stack. You with me? Once you know the number of bills in each stack, then you can figure out the height of the stack. How high is that stack of bills? Be careful, because this will give it to you in inches, and the answer is in feet. Okay? If you're having issues with it, you can drop by. I'll be around this afternoon. I'm okay, nudging you in the right direction on this. So if you're having trouble with it, please let me know. But the right answer is there. It is one of the options. I think the other four, the four prior to that problem, I think they were more straightforward. But if they're not, you let me know, okay? You can use resources, and I'm a resource to you. I mean, I like to think of myself, as more than a resource, but I can help you. You understand? They pay me to help you. They pay me lots and lots. Well, not lots and lots, but they pay me enough to help you. So it's my job to help you. And if you ever feel that you're falling behind, and some of you might even feel that you're falling behind even now, then please come see me, because now is the time to see me, not middle of the semester, end of the semester. Right now is the time to see me. If you're feeling overwhelmed, now is the time. Okay? Homework assignment is due tonight at midnight. Important or not important? Very important. Okay, it counts as an exam. Like all the homework assignments that you'll have this semester count as an exam. And then also, I'll take some questions from this exam, from these homework assignments, and put them on the test. Just a few, but enough. That's a letter grade. A few is a letter grade on an exam. Okay, let's look at our concept test, the one that we were doing last time. I forget where we left off. I'm sure somebody will tell me. Awesome. I know we did these first few. Which one did we leave off at? We did this one, right? Yes, we did that one. Oh wait, no, I'm sorry. We're going to wait, because we haven't done trig yet. So let's just hold off on this. And after we do our trig refresher, we'll pick back up on that. I'm sorry. Go back to your notes in your workbook. All right, so now we're going to look at estimates in order of magnitude, and students sometimes have trouble with this. I'm going to do some examples for you. I think that's the best way to go about this. So whenever you're estimating something, you're really looking for something within an order of 10. Right? I'm an astronomer, so we're all about getting things within an order of 10. We're not really worried about the details of the number, but do I have the right order of magnitude? Is it 10? Is it 100? Is it 1,000? So when you're thinking about estimates in order of magnitudes, and you'll have some multiple choice questions on the test, don't try to be exact, just think about what is this approximately. And then when you do that, I'll have the answers spread out enough so that you'll be able to pick out the correct answer from your approximation. You'll just pick the closest one. All right, you do need to know, however, to do these orders of magnitude, the metric measurements that we use. And so I brought some. I think a meter, you guys know, a meter is 39 inches roughly, a little more than a yard. And so this is a meter. And so you want to be able to take this as your standard and say, what is the width of this room? What is the width of this room? Do you think it's 2 meters, 20 meters, 200 meters, or 2,000 meters? What do you think? If you were given those 4 options, what would you say the width of this room was? 20, right? It's not 20 meters. I'm just guessing it's probably more like 15 or whatever. But if you were given those options, you know it's definitely not 2, and it's definitely not 200. Likewise, I could do a similar thing where I asked you what is the area of this room, in which case you'd have to estimate the width of the room, say 20 meters, the depth of the room, whatever you think that might be. Would it be 8 square meters, 80 square meters, 800 square meters, or 8,000 square meters in this room? What do y'all think? 8, 80, 800, or 8,000 square meters in this room? 800, right? So order of magnitude, you know it's about 8,000. That's like some ginormous house, right? 8,000 square feet. And you know it's not 80 square feet. That would be like 2 meters, about this length, down by 40 meters. So it's not that. It has to be 800 of those options. So you could have something like that. You also need to know, this is about 3 feet. A centimeter is about the width of your pinky. It's 1/100th of a meter. About the width of your pinky. Goodness, God bless you. All right, so in a similar way, be able to describe what is the length, width, or area of an object in centimeters or in square centimeters. A kilometer is 1,000 meters. What is it in miles? 0.6 miles, excuse me. Isn't that right? Yeah, because a 5K is 3.1 miles. Yeah, so about 0.6 miles. So about a half a mile. All right. You'll also see a kilogram. I'm going to pass around a kilogram. You may or may not know a kilogram, but this is a kilogram. So that cylinder that we talked about, it has a mass that's about equal to this. That's 1 kilogram. So just pass this around. A kilogram is a couple pounds. A typical person is about 70 kilograms. Just for reference. So a kilogram is about 2 pounds. It's about 2.5 pounds, really. And just for reference, a typical person is about 70 kilograms. So, about a 160-pound person. It's about 70 kilograms. And a gram is, well, it's 1,000th of a kilogram. And it's going to be about the mass of a penny. All right, so for example, well, what is the volume of this room? Why don't you just take a moment? We've already told you what the area is roughly, or we sort of have this idea of what the area is, say 800 square meters. It's a smallish house, this room, right, 800 square meter house. What then is the volume of this room? What would you say is the volume of this room? Just take a moment and think about it, and then write down your answer, and I'll ask you what you think. Okay, what do we think the volume of this room is? Okay. So you took it to be about 3 meters tall. Yeah, that's probably about right. How about 2 meters? And then you throw another meter on top of that. Yeah, so it's going to be about 2,400 meters in this room. So you need to be able to look at a physical object. On the test, you'll have that physical object in the room somewhere. Sometimes I like draw a box on your sheet of paper. Sometimes I'll pick out something in the room, like this projection screen. We'll have a question like that in just a minute. Or the room itself, or the table of your desk, something that you can see. And I want you to be able to take that and tell me what is the length or width of that object, what is the area of that object, and or what is the mass of that object. Hey, what's the mass of your head? Now, some of us have bigger heads than others, right? Well, what is the mass of your head? Think about it for just a moment. In kilograms, what would you say is the mass of your head? Well, would it be 1 kilogram, 10 kilograms, 100 kilograms, or 1,000 kilograms? Let's do that as a clicker question. Is it 1, 10, 100, or 1,000 kilograms? The mass of your head. What is the mass of your head? You just want to get the closest answer that you can get. All right. Let's stop at, say, 35. 35. Okay, good. Listen, your head, 2 pounds, you gotta have a tiny head to have a 2-pound head. So we would take the next one, 10 pounds. That might be kind of a big head, but it's a good approximation of what your head is. We're looking for the best answer. And in order to know that, you need to have some feel for what the object is. And then also know what are the kilogram, the meter, the gram, and the kilometer. What's the area of your desktop? Let's see, what is that desktop? Is it A, 4 square centimeters, B, 40 square centimeters, C, 400, or D, 4,000? What is the area of your desktop? 440, 400, or 4,000? Do an estimate. All right, let's stop at 40 seconds. 40? Okay, so let's see. We have some splits here, but the answer is C. The reason it's not B, well, your desktop is about this long, and 20 centimeters is about that. Actually, it's a little more than 400. So your desktop is about that wide. It's kind of a small desktop, isn't it? No, we're going to take our exam in a different room. So, but anyway, your desktop is about this wide. It's about 20 centimeters. And then it's similar, about 20 centimeters long. So 20 times 20 is 40. Now, it's 400 rather. If it was 40 square centimeters, it would be this wide, and then it would be like this long, because 20 times 2 is 40. So it's definitely not, a long strip that's only 40 square centimeters. All right, so it's going to be 400. Let's try another question. What is the area of this projection screen at the front of the room? This screen right here. What is the area of this screen? Is it 1, 10, 100, or 1,000 square meters? So you want to think about what is the width and the height. All right, many of you have the right answer. A few of you don't. Some of you think it's 1,000 square meters. Not 1,000 square meters. That would be like, what, 30 by 30 meters. 30 meters. All right, let's stop at 110. All right, good. B is the right answer. It's going to be 10 square meters because it's roughly 3 meters by 3 meters. It's actually a little bit less than 10 square meters. But as an order of magnitude, it's definitely not 1 square meter because a 1 square meter screen would be like from here to here. And it's definitely a lot bigger than 1 square meter. And likewise, it's also definitely not 100 square meters because that would be 30 feet by 30 feet, 10 meters by 10 meters. So the only reasonable answer is B. B is the only reasonable answer. Listen, these take practice, and I really want to see more than 90% on these. But I recommend that you go through the old tests, and you'll see different variations of these problems, and just practice with those, keeping in mind what is a meter, what is a kilogram, what is a gram, and what is a centimeter, and what is a whatever the ones that I listed. Because I'll be asking you to estimate the mass, length, area, or volume of objects that you'll see in the room, or that you'll know very commonly. Okie dokie? We can do that? 1 or 2 questions on the exam. Now let's look at coordinate systems. You'll have a specific question about coordinate systems likely on the exam, but more importantly, we're going to use them throughout this semester and next semester. So they're important. Coordinate system, and fortunately you've seen them before. I know you've seen them in middle or even middle school or high school. But we'll use a coordinate system to define a point in space. We have x, y coordinate systems. And then there are 2 types that we'll use. The Cartesian coordinate system is one that we'll use mostly. That's where you have x and y. And on the other hand, the polar coordinate system is one that we'll use a little bit later, and that's where we have r and theta. In a 2D system, you just have x and y. In a 3D system, which we're not really going to see at all, the 201 students see that, but in a 3D system, you have x, y, and z. It's useful to know the quadrants in the 2D system, by the way, just for reference. So this is our first quadrant, our second quadrant, our third, and our fourth quadrant. Because we'll often refer to our coordinate system by its quadrant that we're in. It starts at the x-axis, and then it goes counterclockwise until you come back around to the x-axis. 1, 2, 3, 4. It's actually fairly useful to know the quadrants. Notice here, if I have a point, say 2, 3 right here, my first point is x, so I go 1, 2, over, and then I go 1, 2, 3, up. That's how I find my x coordinates, or my xy coordinates. And then also down is negative, to the left is negative. This is called a right-handed coordinate system. If you have a left-handed coordinate system, it's switched back. But as you know, like the world is slanted against left-handed people. Right? Yes. Okay, so I'm left-handed too. See, we just connected. I just connected with all the left-handed students. Okay. We'll look also at a plane polar coordinate system. This isn't terribly important for right now, but it will be when we get into chapter 6, I think, where we're doing rotational motion. And when we have a plane polar coordinate system, usually you do xy coordinates where you go over a certain amount and then you go up. Well, here, with the plane polar coordinate system, you don't do that at all. Instead, you have a distance r. This is my distance r. And then you have an angle theta that's measured from the positive x-axis. We'll see that again when we see rotational motion. I'm just throwing it out there, but not important for right now. Trigonometry, how is very important for right now, and you will see this. You're not going to see plane polar coordinate systems on the first exam. You'll see it after we present it in rotational motion. However, you will see specifically trig questions on the exam. 1 or maybe 2 questions on the exam. The exam's a total of about 25 questions, 25 to 28. But I'll have some basic trig questions. Trig is required, of course. I know some of you may have substituted something else for that. Let me tell you the trig that you need. You need to know right angle trigonometry. You need to know your Sohcahtoa, and you need to know your Pythagorean theorem. So let me just review that right now. So with right angle trigonometry, when we're dealing with right triangles, a couple things that we need to recognize. First of all are how the different sides are related to one another. Now notice here I have the sides labeled, and they're labeled according either to x or y. X is side to side, y is up and down. Or they're labeled according to adjacent, opposite, adjacent to the angle theta, opposite to the angle theta. So adjacent side is right up next to this angle theta. The opposite side is right across from this angle theta. So if I did my angle over here, this would still be x, but then it would be opposite, not adjacent. You follow what I'm saying? Y'all remember this from high school? Yeah, or maybe even here. So for example, if I did this differently, where I had this as my angle, then this would be the opposite side to that angle, and this would be the adjacent side, but we would still call them x and y, because that's dependent, is it side to side or up and down. And then this is called the hypotenuse. Hypotenuse is just that side that's opposite the right angle. So this is our right angle. The hypotenuse is opposite that right angle. And sometimes we call it R, which is a throwback to that plane polar coordinate system. Okay? Now, Sohcahtoa defines, or whatever, I think some old hippie or whatever, y'all have your thing that you remember that? It's useful to know this, and we're going to use them a lot in chapters 3 and on, even into next semester, because we do a lot of vectors. SOH, that's sine of theta, equals opposite over hypotenuse. So for example, the sine of theta in this case would be y over r, e.g. It's not always going to be y over r. It depends what angle you're working from. So for example, if I want to know the sine of phi, which would be opposite over hypotenuse, it would be x over r. It depends what angle you're dealing with. So that's SOH. The cosine of the angle theta is adjacent over hypotenuse. And in this case, it's going to be x over r. And then TOA, the tan of the angle theta, is equal to opposite over adjacent. Or in this case, that's going to be y over x. So you need to know your sine, cosine, and tan functions, because we'll use those a lot beginning in chapter 3, and then throughout the entire semester. But you're going to see it just as a set apart trig question. I'll give you a triangle, and I'll ask you what is the angle, what is the side, on and on, about the details of that triangle on this next test that deals with probably chapters 1 and 2. Okay, also sometimes, the Pythagorean theorem describes the relationship between the different sides. You might have seen this in terms of A, B, C. So I would call this A, this B, and this C. And so the Pythagorean theorem says that A squared plus B squared equals C squared. That's stuff that you should have already had, but if you're struggling with that, please come see me. We'll have some practice questions. And there are certainly some in the homework as well, that practicing with, working with right angle triangles. Sometimes you need to find the angle. So say, for example, I have a triangle that looks like this. Say this is my angle theta, and I know that this side is 4 units long, and this side is 3 units long, and I want to know the angle theta. What am I going to do? Well, I say the tan of theta, which is opposite over adjacent, Sohcahtoa, T-O-A. Tan is opposite over adjacent. The opposite side is 4. The adjacent side is 3. So I say the tan of theta is 4 divided by 3. In that case, then, if I want to solve for theta, I take the inverse tan of both sides. So I take the inverse tan of this side. On some of your calculators, this might be called the arc tan. It's usually a tan to the -1. And then I would take tan to the -1 of this side as well. See, I'll just try it out, just to make sure that you get what I think you should be getting when you do the inverse tan of 4/3. Just try it out. Make sure that your calculator is in degree mode. It will always be in degree mode for this class, although in calculus, which I know many of you are in, sometimes you go into radians. So take just a moment, I'll ask you in about 10 to 15 seconds, tell me what that angle is. That angle theta of this 3, 4, well, I'll tell you the hypotenuse in just a second. What's that angle, yo? Not everybody at once. It's 53 degrees, right? Y'all got that too? If you didn't and your calculator's not working right, just come see me afterwards. I'll make sure that you get it set up right. But it should be 53 degrees. And by the way, if we wanted to know what the hypotenuse is, that value for r, or sometimes we call it c, then we would say a squared plus b squared equals c squared. 3 squared plus 4 squared equals c squared. This is 9 plus 16 is 25. And then you square root both sides, and you get c is equal to 5. I like special triangles in this class to make them easy. And by the way, the MCAT likes special triangles too, because you can't use, calculator. And so it's useful to just know those special triangles. And this is one of our special triangles, a 3, 4, 5 triangle that has, the angles aren't really nice and even, but it has a 53 degree angle and a 37 degree angle, right? Because these two have to add up to 90. Okay? Let's do this quick test. I want to know, I have this figure, and first thing I want to do is I want to know what r is. Those of you in the back, I know you can't see the options. If you don't have your workbook, just look under the next person. But I want to know on this figure, with xy coordinates -3.5, -2.5, what is the length of the distance r from the origin to the point? And then you can go and answer the next question, which is what is theta? What is r? What is theta? Right now we're asking what is r. I'm going to go and write theta up here too. What is r? What is theta? What is r right now? My wife and I have date night tonight. I'm excited about that. We're going to Grady V's. We have this babysitting co-op with our neighbors, so they take our kids, we take their kids, and it all works out really well. We're going to Grady V's, I think. You ever been there? Grady V's? Anybody work there? You do work there, Garrett? No, I don't. All right, let's stop at 2:05, okay? On the test, 2 minutes for a problem like this. That's really all you should be allowed to do. For the angle theta, I want to know from the x-axis. All right? That's a good point. But this is for r right now. I'm going to stop right now. All right, B is the right answer. The way you do this, notice that we have a triangle right here. It has one side that is 3.5 units long, and one side that is 2.5 units long. And if I want to know r is equal to 2.5 squared plus 3.5 squared, and then I square root that. And if I do that, the answer is 4.3. You know 19 is just a ridiculous answer. It can't be 19, right? So you're stuck then between two of these answers. And by the way, on my test and every other multiple choice test that you'll ever take the rest of your life, it's useful to go through and just say, well, it can't be this. And then you go for those other answers. All right, let's do the angle now. The angle as labeled on this figure, which is from the positive x-axis. That's sort of a typical way to measure angles in a Cartesian coordinate system or in a polar coordinate system. That's what we're doing here, right? R and theta. We're defining the polar coordinates based on the Cartesian coordinates. Remember, you're welcome to ask your neighbors what they put, or even just peer over at their clickers. There is no cheating in clicker questions. You can do whatever you want. Or they might get upset with you. Try to work this problem without working it, because it certainly can do that, okay? Let's stop at 110. 110. 110. 5 more seconds. Okay, good. C is right. As I said, you can work this without working it, because if you know your quadrants and how the angles go through in the coordinate system, I know this is 0 degrees up to 90 degrees. So the first quadrant is 0 to 90. 90 to 180, 180 to, and then 270 to 360. So I know it has to be between 180 and 270. So it has to be then C. But if we're not sure about that, or maybe we have two options between 180 and 270, I figure out what is this angle. I'm going to actually call this angle phi, not theta. And then phi is the inverse tan of opposite over adjacent. That's 2.5 over 3.5, which is going to be 36 degrees. If you don't get that in your calculator, let me know later after class. I can fix it for you. But it should be 36 degrees, but that's from the negative x-axis, so we have to add 180 to it. So it gives us the 216. Which I like trigonometry. It's very useful, actually. Trig is one of the more useful. All math is useful, but trig is quite useful. Oh, that's the end of chapter 1. Let's finish those clicker questions. If we finish chapter 1, we just move on to chapter 2. So it's not like we get out early or whatever. As I said, I tend to not let students out early. Hopefully at the end of the semester, we'll just finish what we're supposed to do, and I'll just give you a day off, hopefully. But I don't guarantee that. But you come here, so why not just stay the whole time, right? That's what I say. You pay to be here. They'll dock my pay if I let you out early, so not letting you out early. Okay, here we go. We have a jet airplane that climbs at an angle of 15 degrees with respect to the horizontal and follows a straight line path for a distance of 400 meters. Let me draw what this means up here. The wording on this is unfortunate. That this distance is 400 meters and it goes at an angle of 15 degrees. 415. 400 meters. And I want to know what altitude does it gain, this plane. We want to shoot for about 2 minutes on this, okay? 2 minutes is about what you need to shoot for. That's it. Some less, some maybe a little more. All right, feel free to ask your neighbors. We're going to stop at 2:25. 2:25. 10 seconds. If you don't know the answer, just guess, okay? 2:25. It's better to get it wrong than not answer at all. Okay, good. A is right, I think. Actually, I'm not sure what the answer is. Let's work it out, okay? I'm pretty sure A is right. 80% of you think it's right. So I want to know what is this value. I'll call it y. And so I know that I have the opposite side here, and I have the hypotenuse. The opposite as it's related to the 15-degree angle. Opposite, hypotenuse, what is that? So, right, sine is opposite over hypotenuse. So I say that the sine of 15 degrees equals y over 400. And so then I solve for y, I cross multiply, or multiply both sides by 400, however you want to look at that. 400 sine of 15. And what did y'all put? What is that? Was it 141? Oh, it's 100. Okay. Is that right? That's what y'all put. Yeah, so 100 meters is the answer. Okay? By the way, you can look at this. Which of these answers is just ridiculous? 390, right? Because I got an itty-bitty angle. In fact, I didn't really draw this correctly to scale. Really, if I was going to draw this thing to scale, it would sort of look more like that. That's probably even more than 15 degrees. But yeah, it's a small angle, and so the elevation is going to be quite a bit less than the hypotenuse. Yeah, that's about 15 degrees. Okay? All right, notice this expression, y equals x squared. Which of these statements is most consistent for this expression? This is just sort of a mathematical question, but we deal with these types of things in this class a lot, where I ask you about the relationships between values, between variables. And if you change one, how does that change the other value? So that's why I'm giving you this now, to help prepare you for that. Listen, more have it wrong than right now, so we might want to ask one of your neighbors what they put, and look for a neighbor that put a different answer than you did. Y'all feel free to share your answers over here, okay? Y'all sharing your answers right there? Sharing answers. I put A, I put B, I put C. How many people got those? What'd you put? Oh, you haven't put it. All right, I'm going to stop at I'm going to stop at 135. 135. Okay, the answer is D. If I double x, then y quadruples. Y is equal to x squared. Imagine if I do something to x, I have to do the same thing to the other side of the equation. So let's imagine that I double x, right? I double that value. But notice that x is squared, so whatever I do to x is like, it's squared. And so if I double x, that means I'm going to quadruple y. If I double y, I increase x by square root of 2, or 1.4. So A is not right. Though I know that it seems like it's right, and then you read it's the first option. It's like, well, it's A. And then you need to read the others. But you need to go through all of these and look at the options. Okie dokie? You're probably not going to have a specific question like this where I just give you an expression, but in the next chapter, chapter 2, we will deal with things like this where we have quadratic equations like this, and I ask you, well, if t changes by a certain amount, what will happen to x, or what will happen to v? And it's going to be the same question as this. Don't worry, you'll get the hang of it. But that'll be for chapter 2, which we'll get to today or Monday. All right, which of the following is dimensionally consistent with 1 over time? So which of these equations gives you 1 over time, or 1 over seconds? And by the way, this capital D is still velocity, it's not volume. Velocity is meters per second. All right, let's do about 15 more seconds. 135. 135. Ask your neighbor, guess, make sure you get in an answer, right or wrong. 135. Okay, A is right. The way you want to do this, I'll show you the option for A. But we do our dimensional analysis. We put in our units for each variable. So V is in meters per second. And then I have 1 over x, which is going to be 1 over meters. See how I did that? This is V. This is 1 over x. Those together give me this. Then my meters cancel out, and I'm left with 1 over seconds, which is the same as inverse time, 1 over time. Okay, folks? Have some more practice. I understand it's difficult for some of you, and I understand that. Let's do some more practice. Which of these is dimensionally consistent that yields a value for acceleration? Let me remind you, maybe you didn't remember the units for these, so let me just remind you that acceleration is meters per second squared, velocity is meters per second, x, our distance, is meters, and t is seconds. And I want to know which of these gives an expression that has the same units as acceleration, or meters per second squared. You'll probably have 1 or 2 questions like this on the test in a few weeks, a couple of weeks, I think. On the right track, obviously. If you have an answer, turn to your neighbor, even if it's somebody that you don't know, or that you find a little scary, and ask them what they put. Nobody's really scary. No. All right, let's stop at 155. 10 more seconds. 155. Okay, good. D is right. Let me show you with D how to do this. And listen, eventually you're just going to be able to look at these and say, oh, that's this. Like, you don't even need to write it out. But V squared over X. V is meters per second. But remember, it's squared, so it's meters squared per second squared. And then X is meters, but it's 1 over X, so it's 1 over meters. And so this cancels with one of these, and I'm left with meters per second squared. These others, I'm left with something else. So like this is meters squared per second squared times 1 over seconds. So it's meters squared per second cubed, not meters per second squared. This is meters per second times 1 over meters squared. So that's 1 over second squared meters. No, 1 over seconds meters, I think. Is that right? This is meters per second times 1 over second squared, so it's meters per second cubed. This is the only one that does meters per second squared. Which point is nearest the y-axis? It's our Cartesian coordinate system. Which point is nearest to the y-axis? If you need to draw these out, that's fine. It's not always obvious. I need a chair for my office. You think I just take this chair? Anybody say anything? Who sits in this chair? Really? Okay? So let's do about 10 more seconds. We'll stop at 1:05. 1:05. That's good. I see a number of you have changed your answer, and that's a good thing, because you had it wrong. Oh, so close. But D is right. A lot of you at first had put C, because you said, well, C has a low value on the y-axis, so that must be closer to the y-axis. But that doesn't get you closer to the y-axis, right? You gotta have a low value on the x-axis to get you closer to that y-axis. So D is the right answer. The one with the lowest x value gets you nearest the y-axis. I got a good joke, people. So, just saying, 90%. Which of these answers is correct as far as significant figures go? You multiply this out, you get 290.136. What's correct for sig figs? You will have a problem like this on your test for sig figs. Probably just one. All right, let's stop at 48, or we'll go on to 50. Oh, look at y'all. You're awesome. That's awesome. A is right. You get 2 sig figs. 8.8 has the lowest number of sig figs. When multiplying numbers, you keep the lowest number of sig figs. When adding and subtracting, you keep the lowest number of decimal places. All right? I don't know if you knew this, but do you know why cows make such great scientists? They do make great scientists. Do you know why? Listen, you don't answer my joke. I have the microphone because they're always outstanding in their fields. All right. Speed of a boat is often given in knots. If the speed of 5 knots were in the SI system, what would the units be in the SI system? All right, let's stop at 40. 40. That's awesome. C is right, meters per second. This happened to me once, but do you know what you're supposed to do if you're ever attacked by a group of clowns? It happened yesterday, actually. Welcome back there. But what do? And you say, I don't know. Go for the juggler. I learned to juggle yesterday. Chi Alpha had a juggling table. And then my kids and I showed them last night. They got pretty good at it. All right, if A is acceleration, V is velocity, and X is position, and T is time, which equation is not dimensionally correct? Which of these equations is not correct? So 3 are correct and 1 is incorrect. Which is that? One question after this. We're going to have time for it. All right. Try to do it in about 15 seconds. Stop at 120. 120. 120. 120. Just guess if you don't know. I'm going away. 125. All right. C is right. Let me just show you for C. Meters per second on the left-hand side. Meters per second squared. Oh, wait, no, that's not right. Oh, yeah, it is right because it's supposed to be wrong, right? And 1 over seconds. So meters per second on the left, meters per second cubed on the right. Now let me see what this last one is. Oh, when you're adding, you keep the lowest number of what? Decimal places. I have no decimal places here, so D is the right answer. All right, D. Y'all have a great day. Have a great weekend. Be safe, and I'll see you on Monday, okay?